Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenter. We do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. This session will run approximately 1 hour with questions throughout. And our speaker today, Sam Wronski, who is a regional cloud advocate. I'll now turn it over to Sam.
Hello, everybody. I'm Sam Wronski. I'm a regional cloud advocate here at Microsoft. My job is to kind of help empower all of you to build and create really cool things on top of Microsoft's platforms. So today we're going to be taking a look at GitHub Actions, and we're going to be taking a look at how you can use those to test Kubernetes environments. So we're going to be using a tool called Kind and kind of introducing that, and then introducing that into GitHub Actions as a way to fuel our test platform. Kind stands for Kubernetes in Docker. What that means is it's going to run your Kubernetes control plane inside of a Docker image for you. So that means that you can actually spin up a Kubernetes cluster locally inside of Docker, and then create a cluster and remove a cluster really quickly, just like you were creating another Docker environment. And the advantage there is that it means that you can actually really easily spin up and spin down environments. You don't need to, for example, create an AKS cluster that is going to be your test environment. The downsides of doing something like that is you then have a persistent environment that's going to maintain your settings over time. And if anything goes wrong throughout your tests, that's going to impact other tests as well throughout the environment. Whereas if we can recreate and build new environments per test, we can actually avoid conflicts with the tools we're creating. So that's sort of what the advantage here is. It's also a really useful tool if you need a local Kubernetes development environment. There are ways to run Kubernetes locally, Minikube, etc. But this is another way. If you have Docker, this gives you a way to run a Kubernetes instance. So the way that works is you just install Kind. There's instructions here. There's a few different ways to do that. You can go and install it from Go, or if you're following further down the instructions, there's a bunch of other options using Homebrew or Chocolatey, depending on whatever platform you're on. So what we're going to be doing is kind of walking through how to run this locally. So you can actually create a local environment and run things there. You can use that for a development environment or something as you're iterating over things. But then we're going to kind of jump over and move to GitHub Actions so that you can actually run this in GitHub Actions and validate that this pod deployment or this pod actually correctly gets deployed and actually stands up and gets into a ready state. That's our test. And that gives you a way to kind of validate that without validating your code works, but not validating that your resource definitions and deployments are correctly defined and are going to do what you think they should do. So this gives you a way to kind of start doing that and making sure that things are going to be fairly good before you get to the point of trying to deploy to your development or staging or production environments. So anyway, that's sort of what we're going to be doing. I just installed all of this stuff again, so I'm kind of relearning it. It's been a while since I played with this. So part of the idea here of the Reactor Code Lab, which is what this show is to kind of walk through and hopefully like learn live about certain tools and things that you can take advantage of. So we're going to kind of be building this as we go. So let's take a look at Kubernetes in Docker. Let's go there and to get started. Let's first look at what we have running in Docker. There's nothing there. So there's no environments running. But what we can do to create one is just create a cluster. So if we run Kind to create cluster, this will be a little faster for me than it might be for you the first time. There's an image here for representing the node that Kind is going to use that is going to get downloaded. If you are running this for the first time, that step is going to take a bit, just because it needs to pull whatever image it's going to use, depending on the version of Kind you're using. So it's going to pull down a version of Kind, and that is going to then get spun up as our control plane and also a worker node that we can actually deploy things to. This does take a little bit of time. So the downside here is if you need to scaffold and build up a new environment for every single test, you might be waiting a little while. This is not going to be super quick, but generally scaling up environments isn't something that is very quick. The advantage here is that it gives you something that can be reproduced. So instead of worrying about, again, deploying to some persistent environment where you have some predefined test environment, and you're just going to deploy everything there, that runs into issues if you start having concurrent testing running. So if you have multiple tests being run at the same time, they'll both deploy to the same environment and potentially conflict or overlap or cause other unexpected behavior. You usually don't want that. It's going to cause your tests to be really flaky, which means they occasionally fail even when they probably shouldn't, or occasionally succeed even when that probably shouldn't have happened either. Typically, it's usually more the false failure rate that gets annoying, because that will cause things like PRs and stuff to block and need to be re-triggered manually in order to rerun. So typically we want to avoid that. And it can just make your testing less useful. If your tests aren't something you can rely on, if it's pretty common that a test failure doesn't indicate that the build isn't correct, getting a test failure doesn't necessarily trigger that response to go and actually find why it failed. You might just take that and go and learn something else. So that's what's going on here. You can see it's going through and starting a few different things. The first thing it does is kind of preparing nodes and then spin up a control plane. In Kubernetes, the control plane is what runs and operates your Kubernetes cluster. That kind of is a general definition of things that aren't necessarily exposed to end users, for example, but are required for the cluster to actually work. And then we get this. So this spun up an entire Kubernetes cluster, and it also configured our Kubernetes context, our kube control context. So if we do kube control get pods now, there won't be anything here, but we can connect. And if we do a Docker PS again, now we have a node. So now I can actually connect to this node and actually interact with it just like I have a normal Kubernetes cluster. So just like you created something in Minikube or something else, I can deploy things here. What I have here is just a really quick EngineX thing. So we can actually, from either of these, let's do this way. Let's go and deploy something. So kube control apply -f. There's a few different ways to deploy things in Kubernetes. I like apply because it actually just sends the thing out. You can also use, I believe, create, but I actually use that very infrequently, and then delete. But apply is actually going to take a resource, in this case, our pod.yaml, which is just taken from the Kubernetes source, and apply that. And that will automatically handle rolling updates and things for you. So if you try to scale something up, you don't need to delete it and then create it again. You can just apply, and it's going to automatically adjust the configuration and adjust what's in your cluster to match the new definition. So we can deploy pod.yaml. And now let's do this. So the wait command is just going to wait for this resource to be ready. Kubernetes is async, which means when we say apply, what we've done is we've uploaded our configuration to our Kubernetes control plane. That's actually going to then go and figure out what's actually happening, what it should do from this definition. So in this case, we're saying we want a pod we want an EngineX pod from this container with this port. That's what we've said we wanted. That gets sent up to the control plane, and then the control plane figures out how to resolve that for you. So it's going to pull that image and scale it up on one of your worker nodes. In this case, we just have one node. So that's going to get spun up. We can see our nodes here, get nodes. So we just have the one here, which is just running here. You can also see the role is master and control plane. As a note, master has somewhat been removed from terminology in favor of control plane. It kind of more accurately defines it. So if you're talking about those kind of things, control plane in this case, this node is doing everything for us. In some Kubernetes clusters, you might see having multiple different things. And I even believe in Kind, you can even do that if you need multiple nodes. They're just Docker containers, so you can actually append new nodes to your cluster. In this case, this single container here is functioning as everything. So it's handling everything. But now our wait condition returns, which means if I get pods now, we now have a running EngineX pod in this container inside of Docker. So all we needed for this to work at all is just a Docker instance. So we're just using containers to run more containers. So the cool thing with this is now we have an environment that we can recreate. All of the commands that we needed to create this are here. We don't need to go and introduce more resources. We don't need external things. We just need to be able to run containers. GitHub Actions can support containers for you. So this gives you a way to do that. And then we can just start deploying things directly to that. So it gives you a nice way to kind of do all those things. Again, setting up the cluster does take time. So I recommend putting this, making sure this is scheduled after your unit tests, and potentially trying to be a little bit smart about how you're scheduling these things. Otherwise, you might end up trying to wait for a very long time in order to get everything set up. The downside of long tests is if tests takes a long time, people are just going to walk away. At least that's what I do. If my tests are taking too long, I'm just going to go walk away and do something else because I'm waiting for that. And that might be some other development task. I might switch branches and do something else, or I might just go and make tea or something. So typically trying to keep the test times down is going to prevent churn, especially if you get those test times into like hours. That's typically not a good thing. That's really hard to work with. It's just really hard to kind of iterate on something if your tests are going to take you 30 minutes every time you want to run them. So, but there we go. That's, I guess, the quickest way to create this. The cool thing is we can get rid of this just as easily. So if we want to just blow away our cluster, we can just delete our cluster and it's gone. That didn't work. That's the wrong thing. Kind, there we go. So if we run kind delete cluster, that's going to go out and delete that cluster, which means the Docker image is no longer there. And this probably isn't going to work anymore. It might have reset to one of my old configs. So this might be trying to reach out to something that doesn't exist anymore either. But that's gone now. There we go. Yeah. So it doesn't know how to connect back to it because we deleted the cluster. It's gone. So the advantage, again, with tests is we now have something that we can create and delete really quickly, or at least relatively quickly and relatively easily. And it's not something that if you fail to do that, it's going to leave resources in your Azure resource group or something that you don't just end up with a Kubernetes cluster just sitting out there for potentially hours or days or weeks or however long. Instead, it's just contained in this, and we can even isolate this down to a GitHub action. So as soon as the action completes, regardless of whether you cleaned it up or not, it's going to go away. So that's that. That's how you get all of that stuff started. And this is all open source stuff. So this is part of the Kubernetes org. So you can actually go and just find this out on Kubernetes 6/kind on GitHub, and it's all right there. So it's all super easy for you to go and find. There's a bunch of different installation things, and I found this tool super useful. So now we're going to kind of jump a little deeper and try to actually use this in our tests and make something that we can actually run tests against. In this case, we're just going to make sure that what are we talking about? We're talking about Kind or Kubernetes and Docker. It's a way for you to create Kubernetes environments directly from your CLI and then run them inside of Docker. So you don't need to spin up custom environments. Otherwise, they might be required. So instead of, say, going out and creating an AKS cluster in Azure, you can use Kind to do that. and then create a Kubernetes instance either locally or we're going to be bringing it out to GitHub Actions and creating one there so that we can actually run our tests out there. So that's sort of where we're headed right now. We just did a really quick demo. If you want to catch up and sort of see where we were and how this is all working, again, the tool is open source, so you can just go out to github.com/Kubernetes-SIGs. I can drop a link, post a comment. There we go. So you can go there. That will get you this tool, and then from there you can kind of iterate on it and learn a little bit more about it. But again, it's just an open source tool, so you can use it how you will. So there's that. Now we're going to be diving a little bit deeper into this. So let's jump back to GitHub Actions. I don't have anything planned here, so we're gonna kind of go from there. But this is our project. We have this EngineX pod. If you're curious where this EngineX pod came from, it's from this Kubernetes docs on pods. We're just directly using this sample, the simple pod sample. That gives us something really quick. I find EngineX spins up pretty quickly, and it's a relatively small image. So it gives us something to test against, and it's actually something real. So we can actually deploy this and see that it's working. So it's not just something that's going to go away. Have I heard about Gitpod before? I've heard things about it, but I'm not super familiar. So that's a CI/CD tool, correct? I guess do you want to share more? Because I might be something that we should dive into and share a little bit more about. Online ID based on Docker. Oh, I have heard of this. I was looking into this a while ago, but I'm not super familiar with it, unfortunately. Typically what I've been using lately when I want to do like online editing things is either Visual Studio Code. There's remote resources here. So if you go into extensions, there's remote tools. So you can connect over SSH or using containers to develop that way. There's also on GitHub, I think it's like control period something. There's some hotkey to launch a text editor here. I don't remember that off the top of my head, but that can also be kind of handy. I don't remember it, so we're not going to try to figure it out. But let me just stop clicking random things. But there we go. Yeah, that would be cool. Maybe that's something that we should dive into. This show is intended to be kind of driven by things that you guys want to see. So if that's something that people are interested in, maybe we can dive into that next week or something and take a little bit of a closer look at what that is and how we might be able to use it in some similar situations. So let me know if that's something you want to see. Yeah, let's do some GitHub stuff. So what we have here is our basic pod and nothing else. There's really just a README and this pod YAML. All we want to do is make sure this YAML actually works. So what we're expecting is that we deploy this and eventually it gets into a ready state. That's what we're trying to test. We're probably actually going to just test that the apply actually works and returns a valid result. So to do this, we need a GitHub directory with a workflows directory. So that's where your GitHub Actions workflows will end up. You'll see a .git thing here. That's because I actually have it set to actually show that in my Visual Studio Code browser. So it's actually intentionally showing Git as well. But here we can actually go and add our workflows. What we're going to be doing is actually taking a little bit of use from this setup kind tool. So this is another open source tool that is an extension onto GitHub Actions. So it's a public custom GitHub action that's intended to set up kind for you. We're going to talk a little bit about using custom extensions because there's some gotchas there that you should probably know about. But this also kind of gives you a way to set up kind without having to manually inline any custom config or something to install it, it will just get it set up for you. So that's what we're going to be doing. It also has this nice configuration, so we're just going to copy this and paste this into our workflows. So we're going to do on push YAML. There we go. And I'm just going to leave this here for now. What this is doing is getting cluster info and getting the pods. If you're unfamiliar with Kubernetes, that's okay. What this is or at least going over Kubernetes stuff. Kubernetes has a series of namespaces. This is how you would isolate things if you're familiar with .NET. Similar idea with namespaces where you have libraries and things in different namespaces, so they're separate. Same thing here. Kubernetes has custom ones for its internal resources. So things that are hosted to run the actual cluster itself do exist and are part of that Kubernetes environment, but are isolated off into their own namespaces. So that's what this is doing, is grabbing cluster information and getting the pods from the Kubernetes system to display those. And then it looks like just echoing out some other information. All of that seems fine. All this is really doing is validating that we have a cluster. If those don't work, our cluster might not have set up. But what we want here, or at least what this setup kind tool is going to do, just to kind of go back through this, is it's actually going to automatically set up a cluster for you. So by default, it actually runs kind cluster create as part of that action. So it's going to download the tool and then run kind cluster create for you and create a default cluster for you. So that's similar to what we want. If you're using a specific version of Kubernetes, you can provide that version of to kind has specific images for that. And so what that's going to actually do is grab the correct Kubernetes version or the image from kind that aligns with that, and allow you to actually get a Kubernetes environment that actually aligns with the one that you want to test against. Because otherwise it's a little bit less helpful if you're creating a cluster that maybe has a different version than you're expecting. You might get results that don't necessarily indicate the same thing that you're expecting. So that's something that we can take a look at as well. So something I'm a little bit less familiar with, but that's sort of the point here. So who knows? Anyway, what's happening here? We are grabbing a thing to create a cluster and running this on pull requests and pushes. So any pull request that gets opened against a repository and any push to that repository is going to trigger this job. That's going to run a single step or a single job rather called kind that is going to run a few steps. So the first step is checking out. So this is just going to check out your repo. The next one is going to set up kind for us. So that's going to get us our environment there. We should already have all of our code checked out, so that should work. And then this final step is sort of where we're going to insert our testing code to actually run things. And so there's a few things, mainly this line. So you can use third-party plugins or actions as part of your GitHub actions. That's fine. But there are some concerns for this. What's happening here is we're actually referencing somebody else's task, somebody else's action, and injecting this into our potentially deployment pipeline, right? We might potentially be deploying this code or doing something else. And we're pinning it to a specific version, which is good, but we're using a tag. And so when you're using GitHub actions and you're using tags, one of the downsides of that is tags can be overwritten. Git doesn't prevent you from overwriting tags when you're creating actions. So there's nothing actually preventing this from changing on us. It would be unusual, but it is something that can happen. So this is something to be aware of when you're using other things. There are two ways that I've gotten around this. The first one is to fork the repo. And so you just click fork and do that and create a fork. And then you can reference your fork of that. And then you just need to make sure you're keeping it up to date and validating that. If you're using your own fork, that will prevent that from happening because they can't push code into your version of this. The other option, if we go back here, there we go. Clicked too many buttons. Oops. All right. There we go. Cool. Getting lost. That's fine. All right. So we've forked from this. The other option here is to actually pin it to a specific commit SHA. So there's 3 ways you can kind of tag GitHub things. You can tag it to a branch, you can tag it to a tag, and you can tag it to a commit SHA. So every single commit here has a commit SHA attached to it. So what you can do is grab that instead and use that. That doesn't particularly matter, but we can just grab that. So it's a little bit more clunky doing it this way. But if we do this and swap this in here, I believe that should work. I like to typically leave a comment at version 0.5.0. And that gives us a little bit of a note that that's what this is from, because otherwise this gets real confusing real quick. But this will prevent anything from changing because that is actually tied to the commit you're making. So this is just something to be aware of. There's a good chance that this probably isn't a big deal, but there's also a chance that this could become a big thing. Because if this is happening during your deployments to production, for example, if you're running your tests during your production deployments, somebody could come in and change this potentially. And then now you're running somebody else's code to deploy this thing. And it potentially could have changed since the last time you thought that it was supposed to do something. So this gives you a way to hopefully pin it to something consistent so you have a little bit more reliability. I'm not entirely familiar with syntax here, so this might not actually work, but we're going to see. And so we can do this. That should deploy and be fine. And then we should be able to run this kind of stuff. So let's run this and see what happens. We're just grabbing a bunch of config information about our cluster that we create. So what we should be able to do is grab our on push and add GitHub action. Let's commit this and sync this back up. This is actually going to send our action config up to GitHub. That's a push, so it's going to detect that change and run it for us. So if we jump back here to our testing environment or our testing Kubernetes thing, we should now have an action running for us. And so we should actually be able to see that happen. Again, the setting up of kind is going to take a little bit of time. The advantage here is every single time we run a GitHub action, we're running it against a brand new cluster, which means this is going to be our version of this cluster for this action, and then it's going away. It also means if we have multiple actions running simultaneously, they're going to spin up their own Kubernetes environment. So these shouldn't, hopefully, conflict with one another. That's sort of our goal here. We don't want them to overlap, just to avoid causing any other weird issues. So that looks good. We're setting up our node image, trying the nodes, writing the configuration, and doing all the same stuff. This will change a little bit. This looks a little bit different than what we saw when we ran this. So we have the same things, but GitHub Actions, it does not go back up. It's not going to go and rewrite your logs. So what's happening here is when we're checking things off in the CLI version, it's actually adding a new line instead. So that's why you're seeing slightly different logging here. Otherwise, that's what's going on. So the other thing it's doing here is waiting for the control plane to be ready. The control plane node, again, it's an async thing. So it's going to spin that up and then wait for it to be ready. That waiting doesn't necessarily happen if you don't ask it to do that. You can keep interacting with things and keep sending commands to it and doing things like that. but if it's not ready, it's not going to do anything. This is automatically waiting for that control plane to be ready for us, which means that it will be in a state where it can actually start accepting and deploying pods to it. So that's what's going on here. This might take a little bit. It looks like it's waiting for 5 minutes or less for that to happen. And then it should set up. And then we'll jump over to the test afterwards. But again, you'll see this is by far our longest running part of our job so far. This is 2 minutes. Everything else is like a second or less. Granted, we're not really doing anything. We're just setting the job up and checking things out. But this is still going to be a very long part, especially if this is just a small service that you're testing. This part is going to take a little bit of time. So you might not want to create a new cluster, for example, for every single pod that you're going to be testing or every interaction you might have with that. Instead, you might just want one cluster and then figuring out how to isolate those things. Or typically, you're not going to have too many definitions to worry about that in the first place. If you're talking about microservices and you have a single service, you might just want to see, is this pod deployment actually valid? Is the control plane going to accept my configuration? And so you can actually test it that way. So there we go. I guess we'll wait for this. Unfortunately, this part takes a little bit of time. If anybody has any questions, now would be great. Otherwise, we will jump into other things. If anybody has any questions about kind or Kubernetes, that'd be cool. Yeah, here we go. So this is still running. Let's see here. What can we do while we wait? I'm not too sure. So basically what's happening here is it's finishing up this part of the task. It's actually deploying this. Again, we pinned that to a specific commit shell. And then the next thing is it's going to actually run these tests, pull out all of our configuration information. So this is similar stuff. We can actually run this locally. So kube control create cluster. So this will go and create our cluster for us again. Again, doing this locally. This gives us a way to actually test these things. Because we're just testing command line things, we can test this in a few different ways. We can do this as locally first, and then push this up to GitHub. And it should hopefully give us the same results. That's sort of what we're expecting. My kube config is going to be different locally than it would be in GitHub Actions, because we're actually, my kube config has other environments configured for it. So this output is going to be slightly different, but hopefully the cluster information and the pod information should be similar. So this is still going. Interesting. Didn't expect it to take this long, but looks like it's still trying to get set up. So we'll see where this leads, but that's that. Yeah. And then here we're doing a similar thing. We're starting up our control plane and doing all of that. This part takes a little bit slower on my machine, just because it's my machine. But that's what's going on here. And that will give us that environment. What we could do is actually write a test. There's a number of different ways to do this. One of the ways that I've seen is just a shell script. GitHub Actions will return a failure if you return a non-zero exit code, which means you can just write a shell script or a makefile or something to run this test that is going to validate whatever it is you're trying to do. It doesn't necessarily need a fully scaffolded test. It can just be something like test.shell. So let's do this. And I think it's been bash. We want to kube control apply our pod. This will apply our pod and wait for it to spin up. I believe once this finishes, almost there. There we go. Cool. All right, so this finished. It again took a very long time to do this, and then the testing again took another second. So by adding this environment, we extended our actual runtime for this current thing by a number of minutes, which is like a multiple of a few hundred over what it was normally taking. We just had a consistent environment. But again, the advantage here is we're not reusing an environment. I really want to emphasize that because I think that's important. One of the things that I've gotten tripped up on in the past and that I've seen happen is you rely on a single like test machine or test environment to run your tests against. And so maybe you have some golden standard that you've created that is in some specific perfect state. And if it gets messed up, everything breaks. The point of doing all of this, the point of using this to run your tests is that you can get away from that. It means that if one test goes wrong, all of your other ones aren't broken. And you don't need to go and spend manual time going and fixing whatever that golden standard was. Instead, you just have this one environment that can be spun up, run, and then spun back down over and over again. So that's sort of why we're doing this. That's why this is a useful thing. And there we go. If we look at this testing thing, we should actually get a whole bunch of information. So here's our control plane that's running locally, kubedns, and then we end up with all of our internal services. So eventID, and a few other fun Kubernetes things running in there. And that's what ends up getting spun up inside of this cluster for us. So now we're actually going to expand this a little bit and actually start running this shell script against it and trying to run that. So now we have our kind script run. I'm doing bin bash. This is going to get a little weird because I'm on Windows. And so if I try to run this, I think that might cause a little bit of issue. Let me see here. That's not going to work. I haven't tried this before. Yeah, I was worried about that. So it's looking for bash to try to run, which isn't going to happen. I should be able to do WSL and then do like that, I think. And that might work. I don't know if it'll find our Docker instance working. WSL, if you're unfamiliar, is the Windows subsystem for Linux. Whatever I did there, it didn't like. But that actually allows you to run, for example, Ubuntu in a local environment. So if I do WSL, we're going to switch over to our Windows subsystem for Linux. It's asking me if I want to update Z shell. Because I pressed the wrong thing. But this is actually an Ubuntu environment now in the same location, doing all the same things. I don't think Kube control is configured from here, but we can try and see what happens. But I think this is not going to work. Anyway, what that does is kind of give you an environment that you can do. Have I heard about WSA? I have not. I do get tripped up a lot with acronyms. It's something that I've actually tried to avoid as much as I can when I'm talking about things. WSL just it's the command, and so I use it a little bit more. Yeah. What is WSA? Windows something, I want to say, but I don't know. So anyway, let's see here. I think I don't know if I want to do this, but the other way I can think to do this is to actually do it this way. That's the PS1. And we can work from here. This probably is not something that you would want to do in a more production environment. You would want something that was a little bit less hacky, but we have about 20 minutes left in this show. And so I just kind of want to hack something together to get it working, take out some technical debt so that we can actually deliver this. So we're going to apply this. And then what I want to do is get our pods. And we want to see the number of lines here. So I think it's like WC-L, if I'm remembering correctly. let's go test this actually. So if I jump over to my terminal here and jump into a WSL environment, sure, why not? that might have been a poor choice. But what that's going to do is give us a way to actually test these commands out from here. What I'm going to look at is what is the actually let's do something less hacky. That's a much better choice. So we can actually do Kubernetes query pod state. There's a way to get the pod state, describe pod. This is what we want. We want describe. There we go. Okay, JSON path. Cool. And then from here we can do all of that. So let's try this. So there's all of that. More WSL stuff. Let's go and kube control get pods. Did I deploy this thing? I did not. Kube control apply pod. Cool. So we deploy our EngineX pod. That means we now have a pod out there at some point. There's three things that I sort of want to do. First thing I want to do, kube control wait pod, and we're going to wait for EngineX for I don't remember the status for this. There's a thing. Status equals true. That's not correct. So we're just going to kube control wait and get some help. There we go. And let's condition. The name is condition. Cool. For condition equal to true. Apologies for my shell being a little bit weird right now. But hopefully that's good. And then if I pull this up, we're in WSL again. Whoops. Let's come back here. Get our pods, and it's running. So that's not correct. What have I done? Something's not right. Timed out waiting for condition. Pods EngineX. Did I spell this correctly? I did. So I'm not sure what's going on here. For condition equal true. Oh, that's not right either. This is a command that I'm trying to learn currently, so I'm a little bit rusty on it. But wait is actually going to give you a way to wait for things. I mentioned that Kubernetes does things asynchronously. So the commands that you send to it are actually going to get processed on the server, which means things aren't in when they return to you, when kube control returns back to you. It doesn't mean that the pod has been created and exists. What we want to do is actually say, deploy this thing. Then we want to say, wait for it to be in a ready state. And then we want to test that it actually worked. That's sort of the loop that we want to go on. The other thing I think we could do is delete pod EngineX and do an apply with a wait. So if we go here and do wait true, that should cause it to wait for that to happen. I don't think that's how this works though. I'm pretty sure that's not actually how this ends up working. At least I don't remember it being the way it works. So we'll see. But I'm thinking a wait is makes the most sense. And I've done waits previously, and it worked. Oh, I was using a file. That makes sense. All right, cool. So I was testing the wait before because I was trying to learn it. Anyway, we're going to wait for that. So kube control wait for a file pod.yaml for condition equal true. EngineX not found. Perfect. So that's actually that's good because we deleted the pod. The pod doesn't exist. So if our apply doesn't work, we want this to fail, and that's what that would have done. And then if I kube control apply pod YAML done, and then we can wait. go. And so that's just going to wait for us. And then kube control get pods and wait again. Let me make that bigger. Watch. There we go. And so this wait should come back shortly, I think, because that's ready. So I'm expecting for this to say it's good. I'm a little confused why it hasn't yet. Huh. Timed out. Okay. Weird. I don't know why the wait is being... Yeah, I don't know. Apparently I'm doing something wrong, and I don't know how to fix it, so we're not going to debug it here. That doesn't seem like a good use of anybody's time. So I'll figure that out some other time. But anyway, that's the thing. So what we want to do is check what's actually happening here. We want to make sure this actually got deployed. And since this part, the waiting isn't working, we may just have to get the pods and expect this to have something in it. So we're going to expect this to actually return something or have some result for us. So in this case, we're going to say kube control apply -f, and then we're going to describe our pod, ideally. So describe pod. You can use PO as a shorthand for pod. There's other shorthands that you can use for other things like nodes and things like that. But PO is just, it's something that I've been using for a while. So I'm just going to keep using it. And then we're going to check for our EngineX pod. If you're unfamiliar with Kubernetes, this EngineX here is coming from here. So it's coming from our pod that we're deploying. So those should match. What we're saying is go and find something named EngineX and describe it back to us. So kube control describe pod EngineX is going to go and return a whole bunch of information for us about what's actually happening. And if this doesn't exist, we should get some sort of error. So if we run describe pod testing, we'll get a non-zero return here. And so we're going to rely on that as sort of our way of saying, did this work or did this not work? That will give us at least some information about if this actually deployed correctly versus not deploying correctly. And then just testing if it's going to deploy might not necessarily be what you want. You might want to make sure that certain configurations are correct and extend your testing beyond that. For this, we're just testing our configuration actually applies and deploys successfully to a server. So we're trying to make sure this doesn't happen, that we don't attempt to deploy something and it just doesn't work. Or it just doesn't exist. For example, kube control apply -f something else. YAML. That's not going to work either. And so we want to avoid this, because if we try to do this into our production, there's something that's probably not good. So that's sort of what we're trying to avoid, just so that this doesn't end up into our environment and then we have to deal with it. So let's set that up. So again, there's a few different ways we can do this. This is pulling out all of our cluster information. Leave this in as cluster info. And then the other thing I'm going to do is actually name tests. This way we just have a little bit of information about, like, here's the environment, and making sure this way it gives you a little bit of extra information that it was actually set up and running and what the state of that was. And then we can actually go and run this thing. So in this case, we're going to run this, which I deleted. So we're going to do this, apply our pod, and then we're going to describe that back and hopefully get something. Because we've uploaded the thing to the server, even though it's not in a ready state, we should still get information back about our pod, which should be enough for this test case to be satisfied. So it should still pass, but we'll get less information than if we actually waited for it to enter a ready state. I think for these kind of tests, that's sort of where you want to get to, is actually being sure, hey, this thing deploys correctly and gets into a correct state. Because one of the downsides that you can run into is if you are applying something like this, and you maybe don't have those checks in place, your pod might deploy, but never actually get into that ready state and might cause other issues throughout your cluster. So that's one of the tests that I kind of like, is just making sure this thing deploys and it should start up. That's typically a nice thing. So we'll save our test.sh, and we should just be able to run that as is from here. So if we put this vertical bar in, that means that it's a multi-line statement in YAML. So if we go to the next line, we should be able to do test.sh and run that and commit this and hopefully get something back. So we don't need to deploy this PowerShell version. That can just be something that we have locally. Instead, we're updating our tests. There we go. So again, this is going to go and create another new Kubernetes environment for us to test, and then go from there. So we pushed, so that job should kick off for us. Let's go check. Does anybody have any questions about Kind? I've been kind of trying to give like a really quick overview about this tool. I think it's super useful, and I think this is one of the more useful use cases for it is actually using it as a developer environment and using it in your GitHub Actions. So you actually have some way to test Kubernetes environments without either having a designated server for Kubernetes that you're going to deploy to, or having some infrastructure as code thing go out and try to set up an entirely new cluster for you. That's probably fine for larger scale things when you're doing full end-to-end integration tests. But if you're just trying to test, like, does this pod deploy? Maybe that's a little bit much. And hopefully this is a little bit faster and more isolated. And it's going to give you those results a little bit quicker. So that's sort of how I've used this in the past. And it kind of gives you that nice way to work with Kubernetes. So yeah. Anyway, once this gets done, I think we're kind of running out of time. There is a survey in chat. I think the link just showed up. That tells us if this is useful and it's something that you want to see in the future, or if there's feedback you want to give and say, change this, do this differently, whatever. That's also where you go. It looks like the event ID there is 15759. So that would be useful as feedback for us. Lets me know if I'm doing a good job. Other than that, I really hope this is useful. The last one took about 5 minutes to set up, so I'm anticipating that taking about the same time. That means we have about 4 minutes until this finishes, and that's a great time for questions. Otherwise, I can kind of riff on a few other things. There's some other things that I've been intrigued by, I guess. So let's see here. I think the cool thing is, if I scroll down here, there's two things. One, there's a bunch of different ways to install this. So it comes with Brew or Chocolatey if you're on Windows. Gives you ways to set that up. Also, you can install it from Go. But you can also use this to build and run your own Kubernetes environments from scratch. So if you're working on Kubernetes and you want to create an environment that way, this can actually do that too, and build the image directly from that for you. So you actually have your own image based off of whatever source code you're using. So if you're doing local development that way, this might be a way to do that. A little bit outside of sort of my expertise, I guess. But if that's something that you're interested in, this might be a way to start getting started there, instead of trying to scaffold up your entire Kubernetes cluster from scratch, because that can be a little bit of an undertaking. It can be a lot. And so this can, I believe, get around some of that. Another thing, there's a few other commands here. So don't need to wait there. Talked a little bit about a few things going on. The watch command is super useful. It's going to follow your Kubernetes resources. If you're on Ubuntu or something, there's actually a watch command in Ubuntu. I believe it's, here we go, WSL. But I believe there's actually watch here. And then you can watch and run, let's say, echo hello world. And it's just going to, I believe, keep doing that. You can see every 2 seconds, it's going to echo hello world. And then this is actually just showing a console, so it would update automatically for you. The cool thing with the Kubernetes version is it actually subscribes to events. It's not going to be a persistent poll and run out every 2 seconds and keep querying your cluster for more information. Instead, it's going to say, hey, I care about these resources. Let me know when things change. And it's going to send that information back when that happens, rather than you constantly running requests against your server, because that might not be the greatest idea. So that's super cool. And then the other thing, I think Kind has a few other options. So we've mostly focused around create and delete. So you can create and delete different clusters. You can also get them. So Kind git clusters. Looks like you can also get nodes too. I don't know what that does. Kind get nodes. This should just return one because we just have the one node, right? So we get our kind control plane. That's going to match up with our Docker image here, which is our kind control plane. So that's what that is. And then looks like you can load images into nodes. I'm curious what that does. Kind load. Okay. So the load is what you would use if you needed to load in custom images directly. This might be useful if you need to kind of get around having a repo. So for example, I'm thinking if you're building up a Docker container and you want to actually test that, this could actually be a way to get that into your cluster and be able to reference it without having to push it up to a container registry first. That might be something to test because that's all assumption based, but that seems like what that would be useful for. Kind of curious if that actually works. So maybe that's a future topic for us to dive into if this is something that people actually like. Otherwise, maybe not. Yeah, there's that. And then I think the other interesting thing, you can build node images from here, from the build thing. And then the other one is it has completions. This is a typical thing with a lot of different shell scripts. Gives you a completion tool. I think kube control has this too. Lots more things here. Yeah. So kube control completion is going to give you completion stuff for this. So if you want autocomplete, this is how you would tie that in. That's just, if you're into extending your shell, these are how you do that. Yeah. And then hopefully our action has completed. It looks like it failed. Cool. Permission denied. All right, cool. That's a problem. We don't really have time to fix this, but we should just be able to. I forget how I fix this. I believe we can do this, and that should be fine. But we are somewhat out of time, so we're not going to actually necessarily get to rerun this. It's all public though. So if you want to play with this, go for it. Kind is open source, so it's just part of the general Kubernetes area of tools. So if that's something that you want to play around with, go for it. It's super fun, and it makes it a lot more accessible to actually access Kubernetes environments. Potentially, you might be using something like Kubernetes and Docker, or Minikube, which are both fine. This isn't necessarily going to be better than either of those. It's just going to be different, and it's going to give you something that you can actually scaffold up and then pull back down. So if you run into issues, you can just wipe your cluster away and recreate a new one, which I think is really a handy thing. And it keeps everybody kind of in sync if you're all just recreating these new clusters over and over again. So yeah, there's that. I'm going to push this. We're not going to have time to do this, but thanks everybody for watching. I hope this was useful. It's a little bit different than something we've done in the past. But if you like this, let us know in the survey. And thanks so much for watching.
Thank you, Sam, and thank you, everyone, for joining. As Sam mentioned, if you could visit our survey, we'd love to hear your feedback. For the specific event, it's 15759. Until next time, thank you so much. Bye.
Thanks, everyone.